just continue with where we left. Okay, any doubts still here? Were you able to solve these questions? Okay. Now see, criteria for similarity of triangles. So when are two triangles similar? Right, so this says if you have two triangles, right, the corresponding angles, so for example in triangle ABC and DEF, so this means this and this is same, this means this and this is same. 3 angle means this 3 angle and this 3 angle is the same, right? So if angle A equals to angle D, B equals to E, C equals to F, and AB upon DE, so this says and, right, BC upon EF and CA upon FD. So if the angles are equal and the sides are proportional, then the triangles are said to be similar. Okay, so this says and, but later we'll see that if you have all the angles as equal, then the sides are proportional, or if you have sides as proportional, then the angles are equal. So there's no need to have this and, so you can have or, right? So either you prove this or this. Okay, we'll see the proof of that. So you know AAA, similarity, right? So when all the angles are equal, then the sides will automatically be proportional, right? So in proof, whenever we are trying to prove that, say, this AAA similarity, right? For now we don't know that this and this mean the same thing, so we have to prove that if all angles are equal, all sides are proportional. So when these two criteria are met, then we can say that the triangle is similar. Okay, for now we don't know that this corresponds to this and this corresponds to this. So that is why we say both these criteria must be met. Okay. So see, theorem 6.3, if in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio or proportion, and hence the two triangles are similar. So whenever you have to prove any criteria, so say take a triangle ABC and a triangle DEF. So we are assuming DEF is a larger triangle. Okay. Now you are given all the angles are equal. So this is given. A is equal to D, B is equal to E, and C is equal to F. Right, so this is given. Now, inside this triangle, you have to draw a length dp. Okay, so what you are trying to do, you are trying to merge this triangle inside this and then show that it is the same thing. Okay, so what you'll do, just draw a line P such that dp and AB are equal. Okay, then you draw a line DQ such that DQ and AC are equal. Right, so there is no constraint, we can draw these lengths. Now this PQ can be like this, PQ can be like this, or PQ can be a straight line like this. Right, depends on what the value of DP and DQ is. Right, so for now we have just drawn lengths such that DP is equal to AB and DQ is equal to AC. Now we'll join this two length. We are not sure whether the length of this is equal to this or not. Okay. So what we can say in this, between these two triangles, we can say in triangle DPQ and triangle ABC, angle A is equal to angle D. It is given, right? Since these two triangles are similar, so we have angle A and angle D are equal. Then this is by construction. AB is equal to DP and AC is equal to DQ. Right? Does this mean that these two triangles are congruent? Right? These two triangles are congruent by SAS criteria. Right? So now this means this DPQ is the same as ABC. This is one thing. Right? So this means angle P is equal to angle B. Right? But we know that angle B is equal to angle E. This and this are equal. Right? So what can we say from this? Yeah, angle P is equal to angle E. Similarly, can we say angle Q is equal to angle F? Right? Then what does this mean? If this and this is equal and this and this is equal, what does this mean?
So all the angles like
ABC and DEF. But it was already given. Right? That is where we started. So what is the point of proving P and E is equal and Q and F is equal? See, think like this, you have to use, you have to prove that this ratios are equal, right? Because you are given angles are equal, you have to prove ratios are equal. So what will you apply to prove ratios are equal? BPT. So to prove BPT, what is the criteria? Yeah, when is that true?
so PQ should be parallel.
Yeah. So does this somehow prove that PQ is parallel to EF?
Corresponding angles.
Yeah, right. So if this and this is equal and this is equal, which means PQ is parallel to EF, right? Now you can apply BPT. What does BPT say?
dP upon PQ is equal to dQ upon QS.
Yeah. dP upon P is equal to dQ upon QF. Or when you are working with triangles or working with similarity, so now you skip this dP upon P. Instead of that, because we have already seen if we add 1, right? If we add 1, we'll get that the same thing, dP upon dE, because we know dP is a copy of AB, right? So now we need the second triangle. So instead of writing dP upon PE, we can write dP upon DE.
dP upon DE.
dP upon DE.
So much.
So see, you have dP upon PE is equal to dQ upon QF. Right, now I'll just flip this. P upon dP is equal to QF upon dQ. Right, and then add 1 to both sides. Right, so we'll get P plus dP upon dP is equal to QF plus dQ upon dQ. Right, so what is PE plus dP?
DE.
Yeah, so dE upon dP equals to dF upon dQ. right? So I mean, when you have this BPT, you can apply anything. So this by this, or this by this entire thing.
Sir, but what was the use of criteria?
So what we want to do is, we want to prove that DP, so the sides are proportional, right, of the two triangles. So we have to prove AB upon D, right, equals to,
They had to prove that ABC is similar to the EF, right?
yeah. So you already know A, B and C are equal, right?
Yeah,
I mean,
can't,
yeah.
can't we just use AA is similar to
No,
EF?
so you are currently proving that A, right? So you don't know if three angles are equal, the triangle is similar or not. So that is what theorem is. You have to prove that. So you have to prove that if three angles are same, the sides should be proportional.
Okay.
Okay. So AB upon DE is equal to uh, AC upon DF, right?
Yes.
So instead of AB, I should have DP,
Okay.
right? So that is why we are proving DP upon DE and not DP upon PE. Okay. So
Yes.
DP upon DE is equal to DQ upon DF is equal to PQ upon EF. So when you are writing whole triangles, so then this and this is also similar. When you are writing dP upon PE is equal to dQ upon QF, then you don't have to write this. But when you are writing dP upon DE equals to dQ upon QF, so this will be equal to PQ upon EF, right? Because here you are considering whole of two triangles, but in the previous BPT you are only considering dP upon PE, so part of the second triangle, right? So when you consider whole, so all three sides will be proportional. And then you can write, but we know that dP equals to AB, dQ equals to AC, and PQ equals to BC, CPCT,
Yes.
right? So you can just replace it. So AB upon DE equals to BC upon EF equals to AC upon DF, right? And then previously we have seen that if all three angles are equal and all sides are proportional, then the triangles are similar. So you were given that A, B and C are equal to D, E and F respectively. So using that you prove that this is also equal, this ratio, right? So both the criterias are met and now you can say both triangles are similar. Okay. So this proves AAA. So now once you have proved this AAA, you can say that if all three angles are equal, I don't have to look at the ratio of sides. I can say that the triangles are similar.
Yes.
Okay.
Yes.
Then you have the opposite of theorem 6.3 or opposite of AA. If the sides are proportional, then their corresponding angles are equal, right? Or you have to prove that if the sides are proportional, then the triangles are similar. Okay. Again the same thing you have to do. AB upon, so you here you are given the opposite, right? So you are given AB upon DE is equal to AC upon DF is equal to BC upon EF,
Yes.
right? So draw a triangle such that DP is equal to AB, right?
Yeah.
DQ is equal to AC, same thing. Any idea how to proceed further?
So sir, we can say that ABC triangle ABC is equal to triangle DPQ.
Triangle ABC is equal to,
Triangle DPQ.
how?
So it is in question.
No, it is not given. It is only given that the sides are proportional.
Okay, so DP upon PE is equal to DQ upon QF is given.
DP upon,
PE.
yeah, DP upon PE. It is given that, so you are given AB upon D is equal to AC upon DF, right? This is equal to BC upon EF. So this is what you are given. Now you have drawn AB and DP as equal, right? You have drawn DP such that DP is equal to AB. So you can just replace this. So you'll get this thing, DP upon DE, not DP upon PE, right? So DP upon PE is equal to DQ upon DF, right? PQ you are not sure whether it is equal to BC or not. Now what is the next step?
So we flip it, right?
Okay,
So it's like undoing the part that we added, like the reversal.
yeah. So see, you know BPT, what does BPT mean? DP upon PE is equal to DQ upon QF, or DP upon DE is equal to DQ upon DF. Both corresponds to BPT. Right, so when you are given dP upon dE, dP upon dE is equal to dQ upon dF, right? So see, if you just flip this, so you'll get dE upon dP is equal to dF upon dQ, right? As you said, you have to undo this, so you can write dE as dP plus P
Yes.
upon dP, right?
Yes.
dF you can write dQ plus QF. So you can be asked to prove this, the opposite. So dQ plus QF upon dQ, right? If you expand this further, you'll get 1 plus P upon dP is equal to 1 plus QF upon dQ, right? 1 and 1 gets cancelled, so you'll get P upon dP, or dP upon P equals to dQ upon QF. So this also means BPT applies,
Yes.
right? So isn't this the converse of BPT?
Yeah.
So you are given dP upon dE is equal to dQ upon dF. What does this mean?
So it means triangle DPQ and DEF are similar.
The,
No, PQ is parallel to EF.
yeah, PQ is parallel to EF from converse of BPT, right? Any doubt?
No, sir.
From this, you can say P is equal to angle E.
Yeah.
Q is equal to F, right?
Yes.
Now see, Now we just need to prove that ABC and DPQ are the same triangles. Then we are already given sides are proportional. Now we have proved that this is equal to this is equal to this, and this is common across both. So angles will be equal. But we don't know whether ABC and DPQ are the same or not. So we have to prove that ABC is congruent to DPQ.
Yes.
Right? How do we prove this? So we already took AB as DP, right? AC as DQ. So these two are same, right? So AB is equal to DP and
Yes.
AC is equal to DQ, right?
Yes.
Now what else do we need to prove? One more thing, either side or angle or whatever.
Angle A equals angle D.
Angle A is equal to angle D. How?
So we can prove
Yeah, how can we prove this?
by angle sum property.
But we don't know whether P is equal to B and Q is equal to C. We don't know this.
So we can use that isosceles angle triangle property.
So you mean, so see, AB is equal to DP. AB is not equal to AC. So this is not an isosceles triangle. Right, look at what is given.
Yes.
See, from AB upon DE, AC upon DF, we have just used this part. Right, so BPT also says DP upon DE is equal to DQ upon DF. So if you are taking whole side, so this also means equals to PQ upon EF. Right. Now, see if you compare these two, this and this. So don't, when you are using BPT for similarity, don't forget this third thing as well. Okay, so that will be useful when you have to prove similarity. So you can say BC upon EF is equal to PQ upon EF. Right, so does this mean BC is equal to PQ? Right, so can you write this? BC is equal to PQ. Any question? Which means this triangle is similar to this triangle, I mean congruent to this triangle by SSS criteria. Right, so once we know this triangle and this triangle is congruent, now we can prove that in triangle DPQ and triangle DEF, angle D is equal to angle D, which is common, angle P is equal to angle E, angle Q is equal to angle F. So given that the sides are proportional, we have now proved that the angles are equal as well. So if the sides are proportional, the angles will be equal, and these two are the only criteria for similarity, which means the two triangles are similar. By which criteria?
SSS.
Yeah, because we were given the sides. Right, so what are the steps? First thing we do is we draw a triangle inside that triangle such that AB equals to DP and AC equals to DQ. This is the first thing that we did. Right, now we used what was given. It was given that AB upon DE is equal to AC upon DF is equal to BC upon EF. Right, so we wrote that down, and then that led to BPT. right? Once we got BPT, we can say dP upon dE is equal to dQ upon QF equals to PQ upon EF. So there are two versions of DPT. dP upon PE is equal to dQ upon QF. So this is the first version. The second version is dP upon dE equals to dQ upon dF equals to PQ upon EF. So we'll use the second version, right? So we wrote that, and from this thing dP upon dE is equal to dQ upon dF, we can say that PQ is parallel to EF, right? Once we know PQ is parallel to EF, then this and this is same, this and this is same, right? Now we just had to prove this triangle is similar to this triangle, I mean congruent to this triangle. So we already know that DP and AB is equal, DQ and AC is equal. We had to prove that PQ and BC is equal. So we again used this BPT logic. So from BPT we got PQ is equal to EF, and from what was given we got BC is equal to EF, right? From which we got BC and PQ is the same. So we got the third side as well. So once we prove that these two triangles are congruent, then we can say this angle is equal to this angle is equal to this angle, and this angle is equal to this angle. Okay? Any question? So these are direct 4 marks or 5 marks questions. If one angle of a triangle is equal to one angle of the other triangle and the sides including these angles are proportional, then the two triangles are similar. So if one angle of triangle is equal to one angle of the other triangle, say this is equal to this, right? At the same time, the sides including these angles are proportional. So this side and this side includes this side, this angle, right? And this side includes this angle. So the sides including the angle are proportional, not this one. So if you take this angle, then this sides will be proportional to this two sides. Okay, so what you are given, angle A is equal to angle D, then AB upon DE is equal to AC upon DF. Right. So again, what you can do, the same thing. So take a length P, I mean take a point P such that DP is equal to AB. Yeah. 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 So I was saying that we are given angle A is equal to angle D, right? And then we are given the sides that includes the angle are proportional. So AB upon DE is equal to AC upon DF. This is also given, right? Now we have to prove that all angles are equal and all sides are proportional, right? So the first thing you do is draw DP such that DP equals to AB, right? Then draw DQ such that DQ equals to AC, right? So it is given AB upon DE is equal to AC upon DE, which means DP upon DE is equal to DQ upon DF, right? This also means DP upon PE is equal to DQ upon QF, right? Which proves BPT is true here, right? So this means PQ is parallel to EF, right? which means angle P and angle E is equal, angle Q and angle F are equal, right? And then you can also say from BPT, PQ is upon EF, right? So now what we need to prove, just we need to prove that these two triangles are the same, right? So you know AB and DP is equal, AC and DQ is equal, and angle A is equal to angle D, right? So from SAS criteria, you can say that these two triangles are congruent. So then you can say in triangle DPQ and triangle DEF, DP upon DE is equal to DQ upon DF is equal to PQ upon EF, right? So DP is equal to AB, so you can write AB upon DE is equal to AC upon DF is equal to BC upon EF. This is the first thing that you have proved, right? Then you know angle D is equal to angle D common,
Yes.
right? So and you also know that angle A is equal to angle D. So you can write angle A equals to angle D. This was although already given. Then you are given P equals to angle E. Angle P equals to angle E, but you know that angle P is equal to angle B.
So angle B is equal to angle P and C is equal to F.
Yeah. So once this is given, you can prove that all sides are proportional and all angles are equal, which is the criteria to prove that two triangles are similar.
So like the main criteria is both should be there, proportionality of sides and equal angles. But even if only one is there, we can prove the other.
Yeah. And even if you have this thing, SAS, so this is known as SAS criteria. Okay, so even say if you have this, this leads to this. If you have this, this leads to this. And if you have this and this too, this will lead to all of this. Okay. So see, this is similar to congruency. Why do we say if, say, all three sides of a triangle are equal, then everything in the triangle are equal? So we had to prove that first. Then we were able to see, right? When do we say all, two triangles are equal? So when sides are, all three sides are equal and all three angles are equal, then only we can say that the two triangles are the same or congruent, right? So using the SSS criteria, we prove that if three sides are equal, then all three angles are also equal. That means that the triangles are congruent. This is the same thing we are trying to prove. So this is the definition of similarity. So when two triangles are similar, the first criteria is all three sides should be equal, and all three angles should be equal, and the sides should be proportional. But then we have criteria. So if we prove any of this, we can say that the triangles are similar because that leads to this, right? So we don't have to do this tedious exercise every time, like proving the angles and then proving the sides. We can just prove the angles and then say triangles are similar, right? Do you know about AAA criteria of congruency?
So it doesn't exist.
Yeah. Why?
Because if three angles are same, then it is possible that the sides are not the same.
Yeah. So if three angles are equal, then the triangles may be congruent, but it is always similar, right? So there is only one case wherein it may be congruent, when all sides are also, or at least one side is equal, right? Then it becomes ASA,
Yes, sir.
right? Now see, then you have some questions. In figure 6.29, if PQ is parallel to RS, so this is parallel to this. So then you have to apply the logic of parallel lines and transverses as well in similarity, because you are dealing with angles, right? So prove that POQ is similar to SOR. So the order is very important, right? So when you say POQ is SOR, POQ and SOR, that means P should be equal to S, Q should be equal to R, right? So
So
this,
we can say
yeah,
we
go
can
ahead.
say that by alternate angles.
Yeah, right. So, so you can say since PQ is parallel to RS, angle P is equal to angle S. In bracket, you will write alternate angles. Angle Q is equal to angle R, again alternate angles, and
Angle O POQ equals SR.
yeah, POQ equals to SOR, right? Which is what by which criteria they are equal?
Vertically
Yeah.
opposite.
So they are vertically opposite angles. So which means all three angles are equal.
Yes.
Which means this satisfies the AAA criteria of similarity, which means POQ is congruent, similar to SOR by AAA similarity criteria,
Yes.
right? Observe figure 6.30 and then find angle P. So you have to find this angle.
So it should be equal to angle C, right?
How?
Because BC is equal to PQ and AB equals
BC is
RQ.
actually not equal to PQ. BC,
Like it's proportional.
yeah, so BC upon PQ,
Yes.
right? So BC upon PQ is equal to what?
AB upon RQ.
AB upon RQ, and is equal to,
AC upon RQ.
right? So now using this you can map, say this is AB, right? So ABC is similar to, you have RQ,
RQ.
P, right? So if you map any two sides, so here you can say ACB is congruent to RPQ, right? So you can take any order, but the order of the corresponding triangle should be the same. So here it is asking find angle P. So P is equal to C, right? What is the value of C?
40.
40 by angle sum property, right? So this is 40.
Yes.
Again, here you have to prove the two triangles are similar. So in figure 6.31, OA times OB, so OA times OB is equal to OC times OD,
Okay.
right? Show that A is equal to C and B is equal to D.
Yeah.
So how will you prove this?
So we swap the sides so that we get the ratio of the sides.
Okay. So you have OA, right? So you can have two triangles, OAD, right? The other triangle can be OCB,
Yes.
right? So in one side you can take, so you have OA times OB, right? So you can take OA upon OC, right, in one side, and then OD upon OB on the other side.
Yeah.
Why? So you have to have one side of one triangle on the numerator and the other triangle in the denominator, right? So OA and OB are both sides of the same triangle. I mean, they are sides of different triangles. So OA is from this triangle, OB is from this triangle, but they are multiplied. So you have to find something which can be divided. So if you take this OA, and you have two options, OD from here, which will go under division, and OC from here. So OD is from the same triangle, but OC is from a different triangle. So you can take OC, right? Is this clear?
Yes.
Is equal to, this is equal to OD upon OB, right? So
Yes.
OA upon OC is equal to OD upon OB, right? So this is one thing. This ratios are proportional, and then you can prove that this is equal to this vertically opposite angle.
So SA is similar.
Yeah. And then you can check the sides. Say it can be O, OA, and then D is similar to OC, right? OC, B.
Yeah.
Any doubt?
No, sir.
So A will be equal to C, which is here, and B will be equal to D,
Yes.
right? Here instead of CPCT, you have,
Corresponding angles COAT.
yeah. So you cannot write that as CAOT. You can specify that these are corresponding angles of similar triangles are equal,
Okay.
right? So corresponding angles of similar triangles.
Okay.
Okay. So Puneet, we'll stop here today. I'll have to leave for somewhere. Maybe we'll connect in the next class.
Yes, sir.
Okay then. Fine. I mean, try practicing some questions from the exercise. Um, I mean, the first few questions are going to be easy, and yeah, you can stop whenever you feel that the question seems difficult. We'll discuss those questions. I mean, you can start the exercise at least, the initial few questions. So, for example, the first one, it has a lot of questions. All of them are very simple, right? Second one is also simple. Third is also simple. I mean, towards the end, you'll have 2 or 3 questions which are tricky.
Sir, I have actually done till question 12.
You have done till?
12.
Okay. Okay, after that, 13, 14, 15, 16, these are doubts.
No, I have not done actually.
Okay, sure. Okay, let me know if you, I mean, need me to explain any of these questions. So, which means that we can skip this exercise.
Sir, I'll let you know.
Yeah, I mean, other than 12, till 12.
Yeah.
Or
Yes.
do I need to explain any of the questions prior to 12?
No, sir.
No. Okay, then try solving these. So, I mean, then we can finish this chapter early.
Yes.
Okay, and also try to practice proof of theorems, because that those are also very important.